Hello everyone. So in this video we are going to discuss that how we can implement a stack with an array. In our previous video we saw how we can represent a stack, and we also saw that how we can implement a stack using a linked list. So in this video we will see that how we can implement a stack with an array. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So in our previous videos, we saw that stack is a LIFO data structure, which means last in first out. Now if this is a stack, then here in this data structure there is only one end where the elements are inserted via push method, and from the same end the elements are popped out using pop method. So therefore the element which is last inserted, it's first one to be removed. So for example, if we insert 3, then 2 and then 1. So first we inserted 3, then we inserted 2 and then we inserted 1. So the last element which got inserted was 1. So this would become the first element to be popped out. So in this video we will see the implementation of push, pop and peek method with the help of an array, and we will see that how we can implement the stack using an array. So if we are implementing a stack using an array, we need to provide the capacity to it. So as the internal data structure is array, this capacity will tell that we need an array of 3 elements, which also signifies that stack at the start can only hold 3 elements. So internally it would look something like this, that an array will be created of 3 elements having a default value of 0. So currently it's an int array. Therefore the default values are 0. If it is an integer array, then the default values would be null. In our previous videos we also discussed that values are inserted into the stack using the top variable. So here top is an integer variable which will traverse this array and basically insert the elements based on the indexes. So at the start, top is actually pointing to -1. It means the stack is empty. So now let's see how we can perform push and pop operation. So let's suppose we want to push element 8. So usually what happens is we can insert 8 into this array at 0th index, 1st index and 2nd index. Now at the start top is pointing to -1. Now whenever we do push, we first increment top by 1. So currently value of top is -1. When we increment it by 1, it becomes 0. And as it is pointing to 0th index, what we do is we simply assign value 8 like this. So 8 comes here, and if we see the visual representation of stack, it looks something like this, that this is a stack. The element is pushed into the stack and top is pointing to this element. Now similarly, let's say if we push 4. So the first thing we do is we increment top by 1. So top becomes 1 and 4 is inserted at index 1 like this. So 4 comes here, and here it looks something like this, that 4 is pushed into the stack and now top is pointing to 4. So basically when we perform push, we do top plus plus and then we perform array of top and we assign the value which is our data which we have passed into our push method. So we perform these two steps in the push operation. Now let's say if we want to push 3. So first we increment top, it becomes 2, and at array of 2 we assign 3. So 3 comes here, and in the stack it looks something like this, that 3 is pushed and top is pointing to this 3. Now let's say if we push one more element with the data as 1. So here you can see that initially when we created stack, we provided a capacity of 3. It means the stack can hold only 3 elements. Now if we want to insert one more element, we know that there is no more place into the stack. So usually before these two steps, we perform a check that whether stack is full or not. So if stack is full, we throw an exception. So usually how we check whether stack is full or not, we do array.length and we compare it with the size of the stack. So there is a method size. Now here if you see array.length will be 3. And if we calculate the size of the stack is nothing but number of elements into the stack. So we know that number of elements are 3 and array.length is also 3. So how we evaluate this size function is, whatever the value is held by top, which is 2, we do something like top plus 1. So usually this size method will return top plus 1. So here value of top is 2. If we do plus 1, we get 3. So array.length is 3 and size is also 3. So it means the stack is full and we can't insert more elements to it, so we throw an exception. Now let's suppose our stack has 3 elements, 8, 4, 3, and now we want to pop it. So we know that we pushed elements like this and we know that the last inserted element will be first to be removed via pop method. So when the pop method is called, to whichever index top is pointing, that element was last inserted. So now this will be the first one to be removed. So we store this value into a temporary variable and at the end we return this value. And what we do is we simply decrement top. So we do top minus minus. So it looks something like this, that initial value of top was 2. Now it becomes 1. Now here either we can provide a value 0 or we can left this element as it is, because whatever the insertion and deletion we are doing into this array is based on top. So either we assign this value to 0, or if it is an integer array, then we can also assign a value of null to it. And here in the stack it looks like 3 is popped out and now top is pointing to 4. Now let's say if we again call pop. So now top is pointing to index 1 and the value is 4. So now this 4 will be removed. So we first store this 4 into a temporary variable and then we simply decrement top. So top comes here and it looks like 4 is popped out and top is pointing to 8. And similarly if we call pop again, then 8 will be removed and we will decrement top. So now top will become minus 1 and 8 will be popped out. So here you can see if the value of top is less than 0, it means stack is empty. And if we again call pop method, then we also check at the start whether value of top is less than 0 or not. If it is less than 0, then we throw an exception that stack is empty and there are no more elements to be popped out. So now let's move ahead and see the implementation of stack using an array step by step. So this is the code. We have a class stack and as we discussed we have two variables, top and the integer array, and via this integer array we are implementing stack. We have a constructor which takes in a capacity and this capacity is assigned to initialize our integer array. And usually if we don't provide any value to our stack constructor, then the by default capacity is 10. So let's see the demonstration of this algorithm step by step. So we will create a new stack. We pass in the value as 3, which would be our capacity. So the constructor will be called capacity is 3. And we know that at the start, when the stack is empty, top is pointing to minus 1. So value of top is minus 1. And we will initialize the array with our capacity of 3. So it looks something like this, that it has capacity to hold 3 elements with index 0, 1 and 2. And if we visualize the stack, it looks something like this. So when we initialize stack, at the start the stack looks something like this. Now let's discuss the push method. So let's suppose we call push method and we need to push a value 8. So the data is 8, which we need to push into the stack. Now before pushing 8 into the stack, we first check whether our stack is full or not. So by full we mean that internally it's an array, and let's say the capacity of array is 3. So we check whether this array already contains 3 elements or not. Because if the array has 3 elements, then we can't push 8 into the array. So how we check whether stack is full or not? We call isFull method. Now isFull method returns a boolean value which is true or false, which says that the stack is full or not. And inside this method, how we check whether stack is full or not? We simply compare array's length, which is 3. So array dot length is 3 because the array contains a capacity of holding 3 elements. So array dot length is 3. And in the implementation of stack, we also provide a size method. Now this size method will actually give us an information that how many elements are currently into the stack. So when we will call the size method, it actually returns an integer value, and what we actually return is top plus 1. We are returning top plus 1 because let's suppose we have filled all the elements into the array. So top will be here, and if top is at this index, so the value of top will be 2. But if we see the size of the stack it is actually holding 3 elements. So we simply return top plus 1, which actually tells what is the size of the stack. So we simply return top plus 1, which says that how many elements are currently into the stack. So currently value of top is -1. If we add plus 1, the value is 0. It means currently in the stack there are no elements. So it returns 0. So 3 is not equal to 0. It means this condition will be false, and false will be written from this method. So the condition in if block comes out to be false, that stack is not full. So now we can push this data into the stack. Now the first thing we do is, as top is pointing to -1, and we are inserting the elements into the stack using an array. So the first place to insert is at 0th index. So at the start, first we will increment top. So value of top will become 0. Top will point to the 0th index. And then using array of top, we will assign the data. So here array of 0, we will assign a value 8. So 8 will come here like this. And if we visualize the stack, it looks that 8 is pushed into the stack and top is pointing to it. Now let's say if we again push a value 4. So the data is 4. We check whether stack is full or not. So array.length is 3, and then we will evaluate the size. And currently we know that stack has one element, which is 8. So when we will do top plus 1, value of top is 0. So 0 plus 1 will give 1. It states that the size of the stack currently is 1 because there is one element. So 3 is not equal to 1. So false value will be returned from here. And the if block won't get executed because isFull will return false value. Now we will increment top because the next value we need to insert is here. Current value of top is 0. So when we will increment, it will become 1. And now to array of top, we assign the data. So array of 1, we assign the value as 4. So 4 will come here. And if we visualize the stack, it would look something like this. That 4 is pushed into the stack and top is pointing to 4 now. Now let's say if you want to push a value 3. So data is 3. We check whether stack is full or not. So array.length is 3. And size of the stack is 2, which is top plus 1. So value of top is 1. 1 plus 1 is 2, which states that stack has 2 elements. So this method will return 2. And 3 is not equal to 2. So this method will return a false value. So this if block won't get executed. Now the next value should come here, because this space is occupied. So we increment top. Top becomes 2. And at the second index, we insert data, which is 3. So 3 comes here. So if we visualize stack, it looks that 3 is pushed like this and top is pointing to it. So now let's push one more element with the data as 1. So the push method will be called with the data as 1. Now here you can see the initial capacity of the array was 3 and stack has 3 elements. It means the array is completely occupied. So when we will call isFull method to check whether stack is full or not, array.length is 3, and when we will call size method, we know that current size of the stack is 3. It simply returns top plus 1. So value of top is 2. So it returns 2 plus 1, which is 3. So the size method will return 3. And here we are comparing 3 with 3. So via this comparison we come to know that the stack has 3 elements and the capacity of our array is also 3. It means that stack is full. So from isFull method, true will be returned, which signifies that stack is full. So we can't push 1 into the stack and this if log will be executed. So we simply throw an exception that stack is full like this, and we can't push 1 into the stack. So now let's look into the implementation of pop method. Now let's suppose our current stack has 3 values, 8, 4, 3. The demonstration we saw in our previous slide. So value of top is 2. So when we will call pop method, usually with the help of top, we actually push into the array, and with the help of top, we actually pop the elements from the array. So in the stack, it looks like that we are inserting element from one end and we are removing it from the same end, and whatever the element was inserted last will be the first one to be removed. So basically top is actually helping us in maintaining LIFO property, that the element inserted last is first one to be removed. So 3 was inserted last because top is pointing to 3. So when we will call pop, the first thing we check is whether stack is empty or not. Because if stack is empty, there are no elements which we can pop. So how we check whether stack is empty or not? We call isEmpty method and we simply check whether top is less than 0 or not. So when we saw that initially when top is pointing to -1, the stack was empty, the array actually had 3 values to be inserted because the capacity of array was 3. So currently value of top is 2 and it is not less than 0. So therefore isEmpty method will return false, that stack is not empty. So this if block won't get executed. And now as we need to pop 3 from the stack, because 3 was the last element inserted into the stack, what we do is we create a temporary variable by name result and we assign value of array top, which means that we are assigning it a value which is being held by second index, because value of top is 2. So we are assigning value 3 to result, and after assigning this value, now we can simply decrement top. So top becomes 1 and it looks like that 3 is popped out from the stack and top is pointing to the element previous to it, which is 4, and at the end we simply return result. So value 3 is returned from this method. Now if we again call pop, so now 4 will be removed. We check whether stack is empty or not. So value of top is 1. 1 is not less than 0. So the stack is not empty. So a false value will be returned. And this if block won't get executed. First we will hold the value from the array at index 1 because value of top is 1. So 4 is assigned to result. Then we will decrement top and top becomes 0. So it looks like this. And if we visualize the stack, it looks like 4 is popped out and top is pointing to 8 now, which is index 0. and we simply return value 4. That 4 is popped out from the stack. Let's say if we again call pop, now 8 will be removed. We check whether stack is empty or not. So value of top is 0. 0 is not less than 0. So false value will be returned. So this if block won't get executed. We first hold the value of the 0th index, which is 8, because top is pointing to 0. So result will have value 8. We decrement top. Top becomes -1 like this, and it looks like 8 is popped out from the stack and top is actually pointing to -1, and simply at the end we return result as 8, that 8 is popped out from the stack. Now here stack is empty, so if we again call pop method, we first check whether stack is empty or not. So here you can see value of top is -1, so top is actually less than 0, which signifies that stack is empty, so true will be returned, and this if block will get executed, and we simply throw a runtime exception that stack is empty, which signifies that there are no more elements to be popped from the stack. So we actually saw pop method, which actually removed the element from the stack, but there is one more method, peek. Now what this method does is, whatever the values hold by top, which actually is our last element inserted into the stack. So if we don't want to remove this element and we just want to see what is the peek element or what is the last element inserted into the stack, we usually call peek method. So when we call stack.peek, so let's say current condition of the stack is like this, that there are two elements 8 and 4, and 4 was last element inserted into the stack. So when we will call peek, the first thing we check whether stack is empty or not. So value of top is 1 and 1 is not less than 0. So false will be returned, that stack has two elements. So this if block won't get execute. So here instead of removing the element from the stack, we are just returning the value stored at the top index, which is at index 1, and the value is 4. So this peek method will give us information that which element was inserted last. So value 4 will be returned from this peek method, and the element will stay in the stack, it won't get removed. It is just giving us an information that which is the last element inserted into the stack, which is our peek element. So friend, this was all about implementation of stack using an array. I hope you must have liked this video. Thanks, have a nice day.